Okay, let's start the next one. So far we have done Laplace. In the last topic we did Laplace with f of t and a unit step ut minus a. What we do is we take Laplace of, first of all, we put e raised to power minus as for the unit step, and then we take Laplace of f of t plus a. Right. Now we are going to do is we are going to take inverse of this situation. Okay, inverse of a function which has e raised to power minus as. So last formula L30, Laplace inverse of e raised to power minus as f of s. So now we are starting with e raised to power minus as already, and we are taking inverse, and there is some function of s here. The answer would be ut minus a, again quite the contrary. Now because of e raised to minus as, because of this e raised to minus as, we are getting ut minus a, and for this f of s we will get this part. Okay, so we take Laplace inverse of f of s and then shift t to t minus a. As you can see, when we were taking Laplace, we were shifting t to t plus a. Now in inverse we are shifting t to t minus a. So we take inverse of f of s, which is f of t, small f of t, and then we shift t to t minus a. So it would look like finally this side. So let's start with a simple example. For example, let's say if we have Laplace inverse of, this is question number 43, Laplace inverse of e raised to power minus 2s over s cube. We can clearly see our f of s here. So here f of s, small, we write it with capital F. F of s is 1 over s cube. E power minus 2s is not part of f of s. Okay, e raised to minus 2s is this part here. So that is e raised to minus 2s. That is telling me about a. Okay, a is 2. Do not count the minus, because minus a, it says here minus a, it means a is only 2, not the minus. All right, so let's use this information into next part, u t minus a. So a is 2, Laplace inverse of f of s, which is 1 over s cube, and then t goes to t minus a, where a is 2. Okay, right. Now what is Laplace inverse of? Let's move this thing a little bit to the left so that we have space for one more step here. Now ut minus 2, we don't need to do anything about it. We have to do Laplace inverse of 1 over s cube. 1 over s cube, we can go back, and here 1 over s cube. So we put n equals 3, we get 3 minus 1, 2 factorial, t power 3 minus 1, which is 2. So that would be 1 over 2 factorial, which is 2 t squared. But then we have to shift t to t minus 2. Okay, as the formula says. Okay, as the formula says, after having the Laplace, we have to shift. So just like we were doing the shift before, in the case here as well, to the plus side, now we are shifting to the minus side. T minus 2, t minus 2 half. So how do we shift? T minus 2 square. As I hope you remember already, we have done this before, that if f of t is t square, then f of t minus 2 is t minus 2 square. Okay, so this minus 2 should go inside the square here. Okay, so we treat f of t as t square, and that's where we put t minus 2. Okay, we replace t with t minus 2. Okay? All right. How about question 46 says Laplace inverse of s e raised to power minus pi by 2s over s square plus 4. Once again, please note that our function here, I'll write it here. So our f of s is s over s square plus 4. Not this thing. Okay? This is separate. This part is only telling me about a, which is pi by 2. Again, remember that minus is not part of a. Okay? Minus a. So it means minus is not part of a. A is only pi by 2. Now we just copy the formula in here, which gives u t minus a, that means pi by 2, into Laplace inverse of f of s, which is s over s square plus 4. Okay. S square plus 4, but then we have to shift t to t minus a, which is t minus pi by 2. So that is u t minus pi by 2. What is Laplace inverse of s over s square plus 4? S over, here it is, s over s square plus 4. Okay? K will become 2. So that will be cos of 2t. Okay? So that is cos of 2t, but then we have to do the shift. Do not forget the shift in all these cases. That becomes ut minus pi by 2 cos of 2 times t minus pi by 2. Again, we must remember that this minus pi by 2 will go inside 2. It will multiply like that. So that gives, well, in this case, no need to expand because we are not going to do any more operations with it. So you can, if you want, you can leave it here. No need to expand the formula for cos because we don't need to do any more operations here. So again, let's just see the details. Cos 2t, so we treat it as cos of 2 times and then something here, t. Okay, this t is going to change, and this t is going to change when we take f of t minus pi by 2. So this becomes cos of 2 times, here it's t minus pi by 2. Okay? Do not be confused with this bracket which we have put already. We'll put another bracket here. Okay? We'll put another bracket like this, or the square bracket if you want, like I've done here. So this t minus pi by 2 is multiplied with 2. Okay? So that's a careful step here. Alright, let's do one last question, which is using unit step in differential equations. Our differential equation is y prime plus y equals 7 times ut minus 1, and initial condition given is y of 0 equals 0. We take Laplace on both sides. Y prime plus y equals Laplace of 7 times ut minus 1. This gives s y of s minus y of 0 plus y of s equals 7 times Laplace of ut minus 1. We have done this. The formula is Laplace of ut minus 1. Ut minus a, Laplace of ut minus a is e raised to minus as over s. So just replace a with 1 here. So that will be e raised to minus s over s. Right. So this side gives s plus 1 into y of s. And y of 0 is 0, so we don't need to do anything about it. It is 1. And this side e raised to minus s over s. And now y of s will be 7 e raised to minus s over s times s plus 1. and now we take inverse on both sides, Laplace inverse s, and we take inverse on this side, e is 1 minus s over s into s. Right, this gives y of t, which is the function we want, and this one is exactly the same which we just did in the last formula, e raised to minus as f of s. Our from here we can easily see, from here we can see that f of s is 1 over s into s plus 1, and a is 1, not minus 1, 1, and 7 is a constant which can go outside. So this becomes, using the formula, ut minus a, which is ut minus 1, into Laplace inverse of f of s, which is 1 over s into s plus 1, and then we must remember to shift it t by t minus 1, and 7 is constant, so we write it outside here. How do we do the Laplace inverse of s, or 1 over s into s plus 1? If you remember, we had to use partial fractions. So here we have to use a over s plus b over s plus 1. It's very easy. I'll leave this for you and I'll write it directly, that it becomes 1 over s minus 1 over s plus 1. It's very easy, so I'll leave this for you to complete. So it is partial fractions. Alright. Okay, so after this step, our question becomes y of t equals 7 times ut minus 1. Remember that it is still there. Laplace inverse of 1 over s minus 1 over s plus 1. Now we can split Laplace over this one and this one, because there is a minus in between. Also, we must remember that we have to shift t to t minus 1. Okay. So this is equal to 7. We have to write every time, and now we'll put a big bracket because we are going to make 2 inside. Laplace 1 over s minus Laplace inverse 1 over s plus 1. You can write, if you want, only once here, t goes to t minus 1, or you can write this with both separately. That's alright. So 7 ut minus 1. What is Laplace inverse of 1 over s? It is 1. Okay, again let's go back to the formula sheet and see. Laplace inverse of 1 over s is 1, and Laplace inverse of 1 over s minus a is e power at. So a here, again sign change, so it's a plus 1, it will become minus t, and then we shift t to t minus 1. There is no t in our first term, so there will be no change here, so it will remain 1, and here we replace t with t minus 1. Again, remember that this minus sign will stay outside. Okay? Minus sign, and in the bracket we put t minus 1. Do not disturb this t. This shift is only for this part. Okay, this part, the inverse, Laplace inverse. Okay? Not for this part. This is more or less it. We don't need to simplify it further, and that's all.